Please welcome Max presenting ImmuneWatch DETECT.
All right, so my name is Max. I'm from ImmuneWatch, and today I'm doing the lightning demo on ImmuneWatch DETECT. So what do we have here? We have a TCR repertoire, and as always, it's a varied repertoire, many different clonal types, and a fundamental question arises: what are these T cells recognizing? What is their specificity? Now, we have developed a software solution that is called ImmuneWatch DETECT that answers exactly this. So for each TCR, it predicts the target of the TCR, and it can process an entire repertoire in just a couple of minutes. For example, here in the middle, we have a TCR that is predicted to target an epitope from MART1, while on the top left, we have some TCRs that are likely to bind COVID. Okay, so what type of input do we need to make these predictions? Now, naturally, we support the AIRR formats, and we only need a couple of columns to get started. So junction AA, vcol, and jcol. Now that we have our inputs, how do we actually make the predictions? So DETECT is a command line tool. It can be run on the terminal, and it's easily installed with a single line command. So let's start making predictions by calling the ImmuneWatch DETECT program. We supply our input repertoire. We specify the output file name. And then very importantly, we also specify which database we're going to use as training data. Now this has a very large impact on the predictions, as DETECT is a scene epitope model. Here we are using the ImmuneWatch database, which is one of the largest ones available, that covers more than 1,700 epitopes. But you can also use popular publicly available databases like the VDJDB or your own custom database. Finally, we enter a license key. And then we can start running the program. And at first it is going to perform some checks, but then it will start making predictions by showing a progress bar. And here we are predicting the targets of 5,000 TCRs, and we just finished in 7 seconds. So we've made the predictions. How does the outputs look like? So for each TCR, we report the epitope target for the TCR together with a score that is the probability of binding. Now we also show both the antigen and the species. So for example, the first TCR is binding an influenza epitope. Lastly, we also supply some sort of explainability. So DETECT explains each prediction by providing a list of reference TCRs. For the first TCR, we see its junction A on the left, and then we see its reported epitope target GIL. Now, for this TCR, we have a list of one reference TCR, where we can see that it is extremely similar to its junction AA, and this is reported to be experimentally confirmed in the reported paper that is also attached. Okay, so we've seen what the tool can do, but how can we actually use it to solve a research question? Now, we're using data from this fantastic paper where they sequenced TCR repertoires before and after COVID vaccination, and they also stimulated with the spike antigen. Now we ask ourselves, can we actually determine which epitopes are driving the immune response? So from the DETECT predictions on this data, we visualize the epitopes that are most prominent in the predictions. Here we already see some epitopes popping up that may be drivers in the immune response. However, we have not taken into account yet the score of the predictions. So let's make it a bit more strict, and let's increase the stringency here below by setting a cutoff of 0.05. And immediately we see already lots of epitopes disappearing. Now we can increase this a bit more as well until we see two epitopes that are very prominent. So on top we have an epitope TFE, which when we hover we see that 55 different TCRs are predicted to bind to this epitope over 35 different samples in the dataset. Now the other epitope YLQ, there are 11 TCRs that are reported to bind to this epitope over 9 different samples. So these two epitopes may be important in driving the immune response in this dataset. Now we can increase the stringency even more by going all the way to 0.3, where only TFE remains, where we are very sure about these predictions and very sure that this epitope is actually driving the immune response in this dataset. So you can follow the exact steps of this analysis on our documentation page. And now, what about the performance and accuracy of ImmuneWatch DETECT? At the end of last year, we were the #1 model in the publicly available IMREP23 benchmark, and you can find more information about this benchmark through Kaggle. Now, you can get access to ImmuneWatch DETECT through our website. It is free for academics and non-profits, but we also offer a free trial for industry users. Now, finally, because we know you guys love TCR so much, we 3D printed one. It is at our booth, but you can also win it by going to this QR codes and trying to predict the targets of this TCR. So thanks for following, and happy to answer any questions.